This is the ultimate PRS rifle, and in this video, I'm going to go through the build from start to finish. Gavin Gear here from UltimateReloader.com. This rifle is awesome. I'm really excited about this rifle for multiple reasons. First, I shot it and it's awesome. Second, this is a prototype of the rifles that we are building and making available to the general public. That's right, more on that towards the end of the video. Let me go over what we've got here. This is a totally awesome package. We've got a BAT TR action. BAT is known for bench rest level quality rifle actions, and this is the tactical version that you can bring to a PRS match. I've got a Bartline 26-inch MTU Contour 5R barrel, and we've got the Foundation Genesis 2 stock. This is a very unique rifle stock made from a material called micarta. You're going to want to check out the in-depth overview I just published on this rifle stock. And we've got a Hawkins Precision bottom metal. This is their M5 DBM. This thing is complete quality from start to finish. I've also got the optional Foundation Arca rail, which mounts directly to the modified Anschutz rail on the bottom of the stock. Totally killer stuff. So let's talk tools and equipment. Of course, I've got the Precision Matthews 1660 TL lathe. I have really come to appreciate its increased mass, its increased rigidity compared to the PM1440 that you've seen in older build videos. The 1440 is a great lathe. I still use it. Up here at the mountain shop, I'm exclusively using the 1660 TL. From Straight Shot Gunsmithing, I've got the True Bore alignment system. This is a very unique chuck system that allows for axial and radial adjustments. It uses a 6-jaw chuck to uniformly grip the shank of your barrel, and you can use those axial and radial adjustments to dial your barrel in down to less than 1/10,000th of an inch. Also, from Straight Shot Gunsmithing, I've got the SSG range rod. It uses 2 pilot bushings. It supports itself on the inside of the barrel. It makes it very easy to use the True Bore alignment system to quickly get your bore dialed in. Really, really good system. From Meditoyo, I'm using a variety of their precision measurement tools, including their 0 to 6 inch digital calipers, their 0 to 1 inch micrometer, their 1 to 2 inch micrometer, and I just got a digital depth micrometer, a really good addition to this suite of tools that I'm using. From Dave Manson, I've got a custom reamer. I talked to Dave Manson himself. I told him we were going to be shooting Lapua brass with a particular neck thickness, and we're going to be shooting the Berger 140 hybrid. This is the custom reamer with geometry he helped design, which it also uses a piloted bushing. Cut a very, very good chamber. I'm also using a Teslong custom bore scope setup on the lathe inspired by my friend Gordy Gritters that makes it very easy and convenient from a tablet to monitor and inspect the chamber as it's being cut. More on that in just a few moments. So let's talk through the lathe work for this particular barrel job. I should mention that this particular lathe, unlike the 1440 GT, has a very long spindle. It's about 26 inches or thereabouts. Whereas the 1440 GT has a 16-inch spindle. Very, very nice for rifle work. In order to address the challenges with the longer spindle, I fabricated this barrel extension. I basically cut down a barrel that I had, a takeoff from a rifle job. It already had a 5/8 by 24 threaded muzzle on it. So I bored out the other end. I used a tap to thread it for 5/8 24. This allows me to extend the length of the barrel so that it can be supported on the outboard end, and then also importantly so that I can run compressed air through the entire assembly to blow out chips and oil while I'm cutting the chamber for inspection and to obviously get rid of chips so they don't get bound up behind the reamer flutes. So I started with the muzzle threading so that I can use this barrel extension. This went really, really well. I parted off the end of the muzzle. I'm using a new Carmex tool holder and Carmex indexable insert that cut very, very fine threads. Now I just went up to visit Greg Sweezy from Gold Creek Rifles to see his setup and to watch him chamber a rifle. One of the tips that I picked up from him is I've got Viper's Venom for chambering, which works great as a cutting fluid with the chambering reamer. But he uses that for cutting threads as well. In fact, for pretty much everything. So I tried that. That in combination with the Carmex, the indexable tool and tool holder worked phenomenal. This muzzle threading job turned out absolutely perfect. The increased rigidity of this machine certainly does not hurt in that department. So I threaded on the barrel extension. I got the entire barrel assembly run through the lathe, tightened the chuck, and then did a rough dial. So here I'm looking to get the muzzle end and the other end within about a thousandth of an inch so that I can do a few things. First is to part off the end of the barrel. For this particular job, I parted off about an inch to get rid of that portion that's not in the same level of specification as the rest of the bore. This isn't entirely necessary because we're going to be drilling and boring and then using the chamber reamer, so that whole portion of the barrel is gone anyways. But I like to start with a kind of a clean end, and I used a high-speed steel parting blade. This is where the heavier lathe just pays dividends. On a lighter lathe, you can run into chatter, you can break your tool, all sorts of bad things can happen when parting. The demons come out of the lathe in those particular processes. With this rigid machine, as long as you've got your parting blade perfectly perpendicular to the work that you're turning, with a bit of cutting oil, use the power infeed, boom, good to go. No chatter, no drama, no broken tools. So with the end of the barrel parted off, I then calculated what diameter drill bit to use and how deep to drill to get that bulk of the chamber material out. And so I ran that in to the appropriate depth, and what this does is it provides clearance for our final dial of the barrel. So here we can use the SSG range rod to get things kind of roughed in. I like to go with a 1/10,000th indicator and read off of the grooves as you're spinning the barrel to get down to that last level of alignment. We're using the true bore alignment system. We can very easily do those axial and radial movements, get everything absolutely perfect. So at this point, we can turn the tenon down to diameter. The BAT TR uses a 1 1/16 by 18 threads per inch tenon specification. So we run it down to about 1 1/16. You can run it at 1 1/16. You can take it down a couple thousandths further. It all depends on your style of threading and how you monitor your process, that kind of thing. But before we thread, we need to cut the thread relief. I like to thread conventionally. The tool goes into the relief. You let the half nut levers loose. It stops the carriage travel. Withdraw the tool, go back and insert. I've got a couple things I want to do on the Precision Matthews lathe. On the PM1440 GT, as you might have seen in some of my videos, I have a threading depth stop for the cross slide. It enables you to get things back to the same position for the cross slide, and then you do your infeed on your compound each time at 29 degrees to work your way in. That's something I don't have here. The MagExact Precision Matthews DRO is awesome. You can get the tool accurate within 1/10,000th of an inch on diameter. That's 1/2 of a 10,000th of an inch on your radius. And so I was very, very quickly able to get the tool back to its default position and then infeed with the compound. But it is faster yet if you have that depth stop, which is something that I'm going to look at doing. And then on the other end, we turn the tenon down for a relief on the other side as well. Before I thread the tenon, I also like to cut the counterbore. The BAT TR uses a counterbore. Some of their other actions, like the Bumblebee for instance, do not. And so this is just one more step. This is just like a standard Remington 700 bolt nose and rifle action setup. This time I cut the last cut in one pass. So I fed the boring bar into the appropriate depth using the DRO as my gauge. I cut the depth cut. I stopped when I was at the appropriate diameter, and then I moved the carriage to cut the rest of the bore all in one fluid motion. And then I've got a slight radius because of the tip of the tool there at the intersection, so I don't have a stress concentration, and it just looks really, really nice. Now it's time to thread the tenon. And again, with using Greg Sweezy's methodology with the Viper's Venom, I lubed it up really good. I threaded the tenon. I always tend to use the rifle action itself for the last few thousandths of an inch to make sure that I have the appropriate fit. Now for me, what I like to do is when the action is being threaded on and you're almost to that shoulder, you have ever so slight rattle. What does this mean? You've got just a little bit of clearance. Not a lot of clearance, but you know that your threads aren't going to bind and you're not going to gall the threads either. At this point, we're ready to start cutting the chamber. And this is where I take a lot of care, a lot of attention to detail. My plunges started at about 200,000ths of an inch because you're not really cutting a lot of material. You're not cutting the shoulder initially. Continued with 200 until I can see chips coming out at a certain rate, and definitely use that feel to know when the reamer flutes are filling up with chips. Don't want to pack them too tight because then you can get scoring. So between each plunge, I would use compressed air, blow all the chips and all of the cutting fluid off the reamer, get it perfectly clean. Use the barrel extension to blow air through and to clear out the chamber from all of the cutting oil and all the chips and so on and so forth. And in order to know approximately where I'm at, I use the go gauge in the chamber. And on the tenon print that Bat Machine provides, they give you the dimensions for where that should land when you're done cutting the chamber. When I get down to about 20,000ths of an inch, I like to install the go gauge in the bolt, put the bolt in the receiver, and then thread the receiver on until it slightly bottoms out. Now you can check your gap, the gap between where the recoil lug is, the end of the receiver, and the shoulder of the barrel. That tells you approximately where you need to be. Now I like to use some Scotch tape on the back of the go gauge that gives you 2,000ths extra, and I chamber to that depth. Because when I tighten the barrel into the receiver, I know there's going to be compression, and that means I'm going to be between the go gauge and that 2,000ths of an inch. So I like to leave things within about a 0.5 of an inch of where I typically am. If I have multiple rifles, that way I can fire form my brass. So I worked my way up, last 5,000ths, last 2,000ths, and then the last cut was 1,000th of an inch, and things landed perfectly. When the bolt handle goes down with that Scotch tape on the back of the go gauge, I like to just barely feel it at the bottom, and that was where I was at, which is totally awesome. At this point, we're going to chamfer the entrance to the chamber so that we don't have a sharp ring there, and then also the inside of the counterbore, both at 45 degrees. Then use some 240 to 320 grit paper approximately to lightly polish the chamber. At this point, I used my Tesla bore scope setup. So I've got a tablet holder back here, and I've got the NTG 100P Tesla bore scope. This is typically used for pistols. It's the perfect length for checking chambers as you're chambering on the rifle. And the check that I'm using here that I'm most concerned about is the transition of the throat, where that rifling starts, the ramp. What I want to see is when I spin the spindle and I'm looking at that throat transition, I don't want to see it wavering side to side, because that means that the chamber is cut off center in that critical area, the area where the bullet starts to engrave into the rifling. And if things aren't aligned properly and that engraving is uneven, the bullet is cockeyed, guess what? It's not going to fly straight, and that's going to harm your accuracy. This is where a custom rifle with an experienced and talented gunsmith is invaluable, because you're going to get much more precise results compared to any factory rifle, and actually a lot of the so-called custom rifles out there. So when I spun the spindle, I saw exactly what I wanted to see. Perfectly straight, perfectly true throat transition. So at this point, we're ready to do all of the finish work on the barrel. I just got my barrel spinner, I got a polisher, I got wheels, I got compound. This is something that I haven't had in the shop before. I've polished barrels on the lathe, which is very time consuming. A proper grinder polisher setup is going to work a lot better with a barrel spinner. So I polished the barrel, I put it in the laser engraver, I engraved the information on the barrel, the manufacturer, ultimate reloader, the twist rate. These are some things that you're just going to need to know when you go to do your load development, or whether you're troubleshooting whether or not a particular SKU of ammunition or a bullet is going to work properly in this particular rifle. I installed the barrel in the action in a barrel vise, torqued it down to 90 foot-pounds, and checked my headspace. I've still got that Scotch tape on the go gauge. The handle did not go down. Whew, that's good. Took the Scotch tape off, put the go gauge back in, handle did go down. So I know I'm exactly where I want to be. No resistance at all. I'm right where I want to be with headspace. And so that's a 0 to 2,000th range. Typical go gauges and no gauges are separated by about 4,000ths of an inch. So we've got twice the level of control on that. I basically want to be right at the go gauge plus just the slightest amount. That's going to ensure that ammunition will chamber reliably, but you don't have excess room for things to rattle around. Good deal. At this point, I installed the Trigger Tech Remington 700 Diamond. I installed the scope. I installed the barreled action in the stock. I torqued the action screws down to 55 inch-pounds as directed by Foundation. I'm feeling antsy at this point to shoot this thing. Now it's break-in time. I don't know why, but I really enjoy this process. There's always that anticipation. How is this rifle gonna perform? So I went through my standard procedure of 1 shot clean, 1 shot clean, 1 shot clean, then 3 shot clean, 3 shot clean, 3 shot clean, then 5 shot clean, 5 shot clean, 5 shot clean. It takes extra time, but I'm not doing a real detailed clean here. I'm basically pushing 1 wet patch through and then 3 dry patches each time. I just want to get the bulk of the fouling out. Things are getting, roughed in here, broken in here. We don't want to leave too much of that material and fouling in there during that process. And what I've typically seen is things come out dirty initially, and they tend to clean up pretty quick if you have a quality barrel like this Bartline. It's cut rifled, it's hand lapped. This is the kind of barrel finish that's gonna really quickly break in. And we had a load, we had done no load development. Basically it was Berger 140 hybrid, brand new Lapua brass that had been mandreled, close to typical cartridge over length of 2.800 inches. We had 40 grains of H4350. By the way, don't use this load data. Always cross-reference with multiple OEMs load data before you use anything like that. And I got a 5-shot group in that initial round that was down at 0.401 approximately. So basically the MOA on that would be in the threes, the high threes. No load development. Again, this is really, really good. The next day, I went up as an extension of this barrel break-in. I put on the Silencer Co. Omega 300, and I shot 2 5-shot groups. The first was with Federal Gold Medal factory ammunition with the Sierra 140 grain Match King. 5 shots went into 0.301 inches, which is 0.289 MOA. With factory ammo, we're not even broken in yet. Now we're talking. I also shot the Berger 140 load. I wasn't as patient with waiting for the suppressor to cool down, so I got some vertical. So I need to redo that test with that Berger 140. But we're gonna go through a complete load workup anyways. We might use the EC tuner brake. I've got the Area 419 Hellfire brake on there that I used for the first portion of the break-in. That's what we're thinking to offer with the rifles, because those work incredibly well. And I totally love the taper mount that they have. So I think you can see why I'm so excited. Total success with this rifle. It's beautiful. It shoots awesome. I think when we're done with our load development, it's going to be even more of a tack driver, if you can imagine that. And as I mentioned, if you go to rifles.ultimatereloader.com, you can see some more information about what we're going to be offering, and you can get on the wait list. No specific timeline yet, but the rifles we're going to build 4 to begin with are going to look just like this. We are really excited about this. I am really enjoying building rifles for myself. I'm now looking forward to building rifles for you all. These are going to be extremely limited edition, and we'll have more information in the coming weeks and coming months. Again, if you want to know more about it, if you want to be notified when these rifles are for sale, rifles.ultimatereloader.com. Here's what I would like to know is, what do you think about this rifle? What do you think about this lathe and the machining setup that I have here? Please drop a comment and we'll start a discussion. That concludes this video, and that means it's time to wrap it up. I hope you liked this video. If you did, please give it a big thumbs up. Also, make your voice heard. If you have something to say, please drop a comment. Make sure you're subscribed with notifications, because you're not going to want to miss the awesome content that is coming up. And finally, flex your reloading pride. You could look great in one of these t-shirts. We've got multiple designs at the Ultimate Reloader store. I'll see you later, because I'm off to go shooting.